Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. So, Assalamu alaikum. This is Mr. Sajid and I welcome you all to my channel Talim for everyone. Welcome to New Syllabus Mathematics Book 2 7th edition lecture series. So, we are going to start with chapter number 10, Pythagoras Theorem from New Syllabus Mathematics B2 Book 2 7th edition. So, in today's video, we are going to see section 10.1 Pythagoras Theorem Introduction. Then we will see when do we need to use the Pythagoras Theorem, and then we will see proof of Pythagoras Theorem, Pythagorean Theorem in this video. Okay. So here is section 10.1 Pythagoras Theorem. So first of all, we should know one thing, that we can apply this theorem, Pythagoras theorem, only on right angle triangle. So now let's see here. This is a figure A, and it shows a right angle triangle ABC. Okay, and here angle C is of 90 degrees. Okay, that is why it is called as right angle triangle. And if we see the opposite side of angle C is the longest side of a triangle. Okay, it is just opposite the right angle, and the right angle is angle C, that is 90 degree. Okay, and next is here in triangle ABC, the side AB is opposite angle C, and it is one of the longest side. Okay, and this longest side of a right angle triangle is called as hypotenuse. Okay, and it is represented by small letter C. Okay, and what about remaining two sides, like side BC and side AC? They are called as perpendicular and base. So what is base and perpendicular over here? So the side that is adjacent to angle B, that is adjacent to angle B, so it is called as base, and the side that is opposite to angle B, and it is called as perpendicular. And whereas base is represented by small a and perpendicular is represented by small b. Okay, so now let's move on. Here it's practice now 0 from this section, that identify the hypotenuse of each of the following right angle triangle. So here is a triangle ABC, and I have told you in previous slide that the side opposite to angle C is the longest side, and it is called as hypotenuse. So here hypotenuse is side AB. So hypotenuse of figure A is side AB, or you can write it as like small b. All right. Next, this is a triangle DEF, and hypotenuse is just opposite angle F 90 degrees. So this is DE is the hypotenuse. Okay, here D is hypotenuse. All right, and it can be represented by small c. All right, and here in this figure, the this angle R in triangle QPR, angle R is of 90 degree, and the side opposite to angle R is called as hypotenuse. So it means that side QP is called as hypotenuse. Okay, so QP is hypotenuse, and in a smaller letter, well, in a small letter, we can write it as small c. Okay. Okay, so it's all about practice now 0 from this section. Okay, so next is when do we need to use the Pythagoras theorem? As I have told you in first slide as well, that when we you can say that we need to use the Pythagoras theorem when there is a right angle triangle. So basically, when to use Pythagoras theorem or Pythagoras formula? So when we know length of two sides, and need to know length of third side of right angle triangle. Okay, it means that we have given with two, for example, we are given with the two sides of right angle triangle, and one side is unknown. So it means that then we can apply Pythagoras theorem. Okay, so what is basically Pythagoras theorem? So here it is a right angle triangle. This is side A that is called as base. This is side B that is called as perpendicular. This is C that is called as hypotenuse. And A is the base, B is the perpendicular, and C is the hypotenuse. And this is the Pythagoras theorem formula. Formula of Pythagoras theorem. Through this, we can find any unknown side of right angle triangle. C square is equal to A square plus B square. Okay, now in next slide, I'm going to tell you that how this formula arrive. Okay, proof of formula I'm going to show you in next slide. So let's begin. So here it's proof. For this I need four right angle triangles. Four right angle triangle. This is one right angle triangle. This is another right angle triangle. This is third one, and this is fourth one. So what I told you that for proving this formula, C square is equal to A square plus B square. For proving Pythagoras theorem formula, I need four right angle triangles. So here it is four right angle triangles. Now I am going to join these right angle triangle in such a way that it will make a square. So this becomes a square. So if you see, if I take this side as of a square, so it means that and we know that all sides of a square are equal to each other. For example, this is A, this is A, this is A, and this is also A. So it means that it is A plus B one side of a square. This is A plus B. Same B plus A, you can say that A plus B. This is B plus A, you can say A plus B. So all sides are now same. Okay, so A plus B. So this is one side. So it means that square of a larger, sorry, area of a larger square is A plus B whole square. As we know that area of a square is length square, length into length. So length square. So here area of a square is A plus B whole square. So area of big square is equal to A plus B square whole square. Okay, now next, this is a small square. If you see, this is a small square and all sides are equal to each other, and the length of all sides is C. So area of a small square is C square. And now if you see, there are four different right angle triangles. So area of right angle triangle is half into B into H, base into height. So if you see, we can replace B by A and H by B. Okay, so area of rectangle, area of right angle triangle is half A into B. So there are four right angle triangles. So area of a small triangle is equal to 4 into half AB. So 2 ones are 2, 2 twos are 4. So area of a small triangles would be 2 into AB. Okay. So I hope so this is quite clear to you. Now next, if you see this large square, area of large square is equal to area of a small square plus area of all four right angle triangles. Okay. So now, big square, area of big square, large square is equal to area of a small square plus area of a small triangle. So it would be equal to A plus B whole square is equal to C square plus 2AB. A small square area is C square and small triangles area is 2AB after evaluating or after solving. Now A plus B square, here we can apply the formula of A plus B whole square. So A plus B whole square is equal to A square plus 2AB plus B square. So A square plus 2AB plus B square is equal to C square plus 2AB. Now in next, we can shift this 2AB towards right hand side or this towards left hand side. It is same because this is 2AB and here its sign are also same. So we can write like A square plus B square. It is equal to C square plus 2ab, this minus 2ab, okay? So plus minus minus, so it is equal to a square plus b square is equal to c square, or you can write it as like c square is equal to a square plus b square. Now we can say that, or it is proved, hence it is proved that c square is equal to a square plus b square is Pythagoras theorem. Okay, or you can also call it like Pythagorean theorem, or why it is used, or you can say that why only right angle triangle is used for Pythagoras theorem, because the square of hypotenuse is equal to sum of squares of their remaining two sides, that is perpendicular and base. In this way, we can say that Pythagoras theorem is only used to find the unknown side of right angle triangle. Okay, it is only applicable to right angle triangle. So I hope so this is clear to everyone, and those who are watching this video on my channel. So thank you for watching. If you like this video, so don't forget to subscribe my channel Talim for everyone, and hit like button and share my video with your family or friends.